Okay, Assalamualaikum and very good morning. So let's continue with the next section, which is still chapter 1, still about the vector function. But now we want to look how can we differentiate and also integrate the vector function. Okay, so for your information, this one is a definition of the vector derivatives where your function now is in the vector form. So how can you differentiate them? So the concept or the definition is similar as the regular function, which mean that when you have the df over dt, f is a vector function, so you have f prime, meaning that if f is the vector function, so the small f, g, h, they are in component function in terms of t. So the way if you want to integrate them, differentiate that particular function, the vector function here, with respect to t, so the component also follow through, which means that for component side, you have to differentiate with respect to with respect to t, and then differentiate g with respect to t, and differentiate h with respect to t. Okay, as for the example here, so we have, okay, I just rewrite on the board. So I put the vector function in terms of component form, where the f of t is given by 3 minus t, component y is 2, and component z is minus 4 plus 3t. Okay, so when you have f prime t or df over dt, so you have to differentiate the first component with respect to t, then you have minus 1, and you got 0 because only 2, right? And then minus 4 plus 3k just pick up 3. So that's why you have minus I plus 3k. Okay, and then the second one, so that is the first example. So now the second example, if your vector function in component form, we have 3 sine t, and component y we have minus 3 cos t, and then 2e to the power of 3t, that is component k, z. So when you apply the derivatives with respect to t, so 3 sine t, differentiate side, you got cos, 3 cosine t minus 3 sine. You differentiate the cos, you got negative sign, so negative and negative become positive. So 3 sine t, and then differentiate the e32, sorry, 2 is 2, then differentiate the e3t, so 3e3t. So what we have is 3 cos t, 3 sine t, and 6e to the power of 3t. Okay, so that's the process of differentiation. Maybe you need to apply the chain rule, so they are all the same. But the difference now is only you have to differentiate component by component. Okay, so the differentiation rule, yeah, so in this case, if you have the summation of the two vectors, if you apply the derivative, so you can find the derivative separately, and then after that you total up, or c here is a constant, so you can multiply first and differentiate, or you can just take out the c and differentiate only for f, and after that you will just multiply the c back. And now the multiplication between the vector and the scalar function. So what you can see here, it looks like you are applying just a product rule, right? The product rule is in the regular function, if you have the u dot v, So u v prime plus v u prime. As you can see that it looks like that. But now it is a combination between the scalar function and vector function. And also for the dot product, whether you just find the dot product first and you differentiate respect to t, or you can apply just like the product rule, f prime g plus f g prime. Okay. So this is the property that I think it is very important for you to know. Okay, especially the thing on the right side, just like a formula. If you don't remember that, if you're not sure, you can just apply, find out this one first, and then after that you obtain the derivatives. So this one, the dot product will give you a scalar function, right? Then that function you just differentiate respect to t. For the next is a cross product. So the cross product is also looks like the product rule. So f prime g plus f g prime. Okay, so this is a composite function. There is a function f in the vector function. Then you need to apply the chain rule. Okay. So now try for the example 6. We want to try for the example 6. Okay, so the example 6, they give you two vector functions as stated here. We are rewrite into a component form. So the first one, you have to find out the derivatives of 3f minus 2g. So 3 and 2, they are constant, meaning that you have to multiply the 3 and the 3 and the vector function f. Okay, so now you want to show you. Okay, so now I'm trying to expand. So 3f, so 3 multiplied by the vector function f minus 2 multiplied by the vector function g, and I'm trying to expand, and now we have to sort them into the component. So component x with the component x and so on. Okay, so now this is the 3f minus 2g. So this is the new vector function. Now we want to differentiate all this expression respect to t. Okay, so the first one is component x. So when you differentiate that, so 903t squared, you got 6t. Okay, sine cos. So you need to, this one, there is a function in a function. So differentiate the outer sine, you got cos. So minus 2 cos. Minus 2 cos of 2 minus t. And then multiplied by the derivative of the inner function with respect to t, you got minus 1. Okay, so that is for the component x. So now you go to the component y, the second one here. So again, there is a function in the function. So cos, we get differentiate cos minus sine. So we got 3 sine of 3t multiplied by the derivative of the inner 3t, you got 3. Okay, and then the derivative of this component, then you will get, I don't have enough space here. Okay, I just continue down here. So minus 3t minus 2, and then you have minus 2e 2t and multiplied by another chain rule. So then we simplify. So then we got 6t plus 2 cos of 2 minus t, that is for x component, and then 9 sine of 3t, that's it for y component, And z component, we have minus 3t minus 2 minus 4 e to the power of 2t. Okay, so now we go to the next example where we have the f dot g. F dot g, we will get a scalar function, and then after that we have to differentiate. So just sort into the component form. So what we have for the dot product, we have to multiply the x component and the x component. So in this case, the x here and the x here should be multiplied. Okay, so that's why we got this 3 plus t squared sine 2 minus t. And then the second term, y component, negative cos 3t multiplied by 0. Okay, and the last one, 1 over t or t to the power of minus 1 multiplied by the e to the power of 2t. And then we simplify. So this one becomes 0. So we have only two terms, this one and this one. Okay, so that is the answer. The answer of the dot product between two vector function. So now you have to differentiate. So next we are going to differentiate that. So f, the vector f dot g will be differentiate by with respect to t. So this is multiplied. The two functions, they are multiplying each other. So you have to apply the product rule. So that's why I put the uv, which means that we have to apply the product rule uv prime plus vu prime. So here the first formula of the product rule, u, and this one is v prime. So u does not change, and v prime means we have to differentiate sign with respect to t. So this one, output function, we have cos, and then multiplied by the derivative of the inner, this is become minus 1. So that's why we have that is why we have negative sign here. So that is the first derivative of the first term. Now we go to the second term. We have another multiplication of two functions, and we implement again the dot product. Sorry, the product, the what we call that, the product rule. Okay, the product rule. We have uv, and again uv prime plus vu prime. Okay, so here okay, down here. So the u and v for the second term, I continue down here. So the first one here is uv prime. So u here is maintained, does not change. And then v prime, you have to differentiate with respect to t. So e to t, and differentiate the 2t, you got 2. So that's why we have 2 here. Plus v u prime. So v here and u prime, you have to differentiate t minus 1. We got negative t minus 2. Now our task is to simplify the form and sort them. Okay, so this is the result that you cannot simplify, so it's just like that. Okay.